Hello, everyone. Welcome to today's webinar discussion on smart plant operations presented by Nextracker. My name is Ali, and I'm part of the marketing team at Nextracker and host of today's webinar. Thank you to everyone who joined our webinar today. Before we get started, some quick housekeeping. We are in the Zoom webinar platform, which works very similar to Zoom meetings that we're all used to. On the bottom of the webinar module, you will see the Q&A chat options. We encourage you to send your questions and we will try to answer as many of them as we can before the end of the session. Before going any further, we want to remind everyone to be safe on and off the job sites, wear your face mask, and always make sure to wear your PPE when you visit the sites. During today's webinar, our speakers will discuss the importance of smart design and the software tools needed to properly care for a power plant. And while having these items covered from the beginning of the design and from the design points, it will help you get through any weather and other O&M activities needed to get your plant running smoothly. Our speakers today are Andrew Chino, Sales Director in Australia and Asia Pacific region for Nextracker, and Andrew Little, Regional Lead Technical Services at Nextracker. Andrew Chino, the floor is yours.
Thanks, Ali. So I took a quick look at the attendees beforehand, the registrants, and so nice to see so many familiar names. Welcome, thanks for taking the time to join. So for those of you who aren't as familiar with Nextracker, just a quick overview. Nextracker is the #1 market share leader in solar trackers. We have been for the last 5 years. We've just surpassed 37 gigawatts sold, under construction, or in operation. Nextracker is part of Flex, which is a $26 billion annual revenue company. We've got a global presence of about 375 staff members worldwide and 8 global offices, one in Sydney being one of them. In 2019, we exceeded 11 gigawatts of shipments, which is quite a milestone for us. And so just wanted to pull up this chart just to show where PV is going in the future. While every year it feels like we're doing so much, that trend is just continuing up and to the right. In the next 10 years, the cumulative PV capacity is expected to increase 6x and then grow 9% compounded annually up to 2050. What's interesting to see is the breakdown by 2050. It's expected to be 60% utility scale and 40% distributed generation. Nextracker really has 2 sides to the business. There's the hardware side, which includes our 1-in-portrait NX Horizon tracker, as well as the 2-in-portrait Gemini tracker. And over the years, we have been working to optimize both for performance as well as for reliability. And on the other side, we've got software and controls. Our flagship products are TrueCapture and NX Navigator, which we're going to discuss today. And I think the software side is of particular interest to long-term asset owners. To me, looking out in the future, it's interesting to see that through machine learning and firmware updates that you can actually have better performance in your plant 5 years from now than day one, which I think is a different way to be looking at it. In addition, through predictive analytics, automation, and smart control systems, you can maximize asset management efficiency and lower operating costs.
Good afternoon, it's Andrew Little here, everyone. So just carrying on from what Andrew Chino was saying in regards to optimization and further enhancements of the product. This is available thanks to resilience being built into the initial design of our tracker. The fact that it is a non-linked freestanding tracker allows us to kind of really push the envelope as to what we can do on the control side of things. And hence that's what's enabled TrueCapture and other offerings that we're working on. So I've just got a brief snapshot here of a typical breakdown of O&M costs for PV systems. The heavy hitters here are really like the inverter, cleaning, vegetation management, and obviously PV modules. The tracking system itself actually comes in number 5, and even the O&M costs on these are coming down with, you know, further enhancements of the product and better quality controls and things. But one of the optimizations that we're kind of really driving with our offerings is that the tracking system can actually impact cost savings in other aspects, such as, you know, if we can control the trackers in a smart way, you know, we can save on cleaning and vegetation management. If we can enact safety stows and things, we can protect the modules better, you know, thus reducing, you know, replacement costs and O&M downtime and things like that. So just to kind of reiterate and touch on a few of Nextracker's industry firsts here. So obviously you're all aware of the fact that our trackers are independent rows and that they're a balanced tracker. So obviously that enables the individual control. They're also self-grounded, so that saves quite a bit of installation costs during construction. The fact that they're self-powered and leverage wireless communications, that means that there's no additional cabling to supply the tracker. And also, given the size of farms these days, other communication strategies other than wireless are extremely challenging, especially sort of when you've got spreads of, so say like 400 meters between blocks. So the wireless communication that we've developed is sort of really, yeah, it's really providing huge benefit there. We've also piloted predictive analytics and digital O&M, and we'll talk more about that a little bit later on. And then as mentioned previously as well, we've invested a lot of time into smart controls and software, be that a TrueCapture offering that many of you are aware, and, you know, more recently with NX Navigator offering, which provides some additional control functionality and additional protection for your tracker assets. Sorry, I had a bit of an issue with the slides here. So one thing I want to touch on as well is our manufacturing process. So we have world-class manufacturing and quality control thanks to Flex's factories and supply chains. Not only that, but we are able to also global diversity with the fact that we not only have factories in China, but also in Brazil and Mexico. And that's really provided huge value to our clients, especially during COVID-19 and with China going offline there for a number of months. So I do have a brief recap on the history of the NX Horizon product. So the NX Horizon, we've essentially got two generations. The generation 1 equipment was in supply and production between the years of 2013 and 2016. And the generation 2 sort of took the learnings and you know, refinements of that was produced from 2016 on to present. The main improvements that are available in the Gen 2 equipment is in regards to the tracker motor. We replaced the brush DC motor with a brushless motor, which offers an extremely low failure rate. The original Gen 1 controllers were a steel unit with a door and access panel. Those have been replaced with a complete factory sealed IP67 rated controller. And obviously with that also came with it some vastly decreased production costs, which is then obviously passed on to our clients. The original slew gears were actually assembled on site, and they actually required annual lubrication. These were replaced with factory assembled units that were sealed for life with no O&M requirements. Then our network control units, the original network control unit offered some rudimentary controls via toggle switches on the front faceplate. Those have been replaced, or the NCU itself has been replaced with a unit that has a much higher processing power. It includes a front panel and localized controls and monitoring for the tracking system. So yeah, it enables O&M guys a lot more than the original product. The damping system has undergone a few refinements, and the module fasteners in particular is one thing to touch on, is the fact that these have proved extremely reliable right from day one, and we've had minor advances in those going forward. So we've actually retained those components.
And so as Andrew mentioned, our system is an independent row tracker, meaning that it operates independently of other trackers. So through this, we've got independent tracker level communications. So the trackers communicate to the NCU, the network control unit, but they each have independent control, which allows us to control the system for production improvements as well as safety stow. The balanced drives system, our trackers are a balanced design, which means that they can quickly move to either a safety stow position or a different position in order to optimize energy production. And then over on the other side, you can see the skinny panel. That's our self-powered smart panel. And Andrew, maybe you can detail some of the benefits of that panel.
So the smart panels are a recent addition to the NX Horizon. One of the really cool things that it allows us to do is it allows us a degree of self-tuning for tracker operation. So we're all familiar with TrueCapture. So essentially this smart panel allows us to detect shade, and we can use that to further tune and optimize the row-to-row control to squeeze those last few bits of, last bit of generation out of the system.
And over time, we've optimized our design. So our tracker is inherently well suited for bifacial modules with gaps at the motors, gaps at the bearing house assemblies. But then a couple of years ago, we actually raised our module mounting rail so that it sits above the torque tube to reduce backside shading. Andrew just went into some of the benefits of the smart panel with shade detection. And then we worked very closely with all of the module manufacturers to ensure that the module is compatible with our system, but also to make sure that it's getting the most out of the module, as well as easy for our EPC and installer partners to install.
Okay, I touched briefly in regards to our engineered fasteners before. So anybody with a mechanical background is familiar to the O&M requirements if you're using a nut and bolt type combination. I mean, these things need to be manually screwed together. They need to be torqued up. But the biggest problem with that is obviously during operation of the asset, you have vibration and other other factors that can cause, these fasteners to loosen over time, which means that there's an O&M requirement to continually, check that these are tight, they're not coming loose, they're torqued up appropriately. Obviously, that adds a huge O&M encumbrance. So the benefit of our engineered fasteners is the fact that once these are crimped up, they are set and forget for life. And thus far on record, we have not had one instance of these engineered fasteners failing, provided they were actually crimped in the first place. These also offer, significant benefit during plant construction, and they can actually improve install speeds by up to 4 times. Now, just another advantage to the Nextracker's design here is the fact that our system is designed for extreme weather. And you'll notice in this picture that all of the critical components, the slew drive, the SPC, the modules, they're all at the top of the pier. So, for example, in a flood condition, these components are inherently already lifted up out of the danger zone. Andrew, what sort of considerations go into the project design phase for when we want to design for extreme weather?
Yeah, thanks, Andrew. Typically, we're looking at the wind speeds on site, looking at the flood height. So we design for 1 in 100 or 1 in 200-year flood heights, and typically just trying to make sure that the top of post height allows for enough clearance for the module and the critical components at various angles.
Thank you. So the next feature of the NX Horizon in particular is the fact that it is self-powered, meaning that the only cable management you need to worry about are those for your DC cabling. Provided suitable use of underground is used at the end of rows, what that enables is a completely obstruction-free access in between all trackers along entire strips of the farm. As you can see pictured here, there's a cleaning rig that is basically working its way down a row, and in the background picture you can see that those rows go for, they span across multiple blocks of trackers completely unobstructed. So just another example of how the O&M costs can be vastly reduced if you choose the right architecture for your system. Sorry, Andrew, are you running this one?
Yep. Next slide, please. I'm going to dive a bit into our smart control system. So as mentioned earlier, TrueCapture is one of our software platforms. It's an intelligent, self-adjusting tracker control system that increases plant production by up to 6%. It generally ranges in between 2 and 6%. It adjusts or it increases the production by continually optimizing the tracking algorithm based on the site conditions. So by site conditions, I mean the row-to-row component. So row-to-row shading basically occurs because industry standard backtracking algorithms are assuming that the site is completely flat and that every panel is at the same height, every tracker post is at the same height. Well, in reality, you've got slope, undulations, and install variances on site. So even on a flat site, you'll have posts in the east to west direction at varying heights. And because of that, you get shading. So what TrueCapture does is it breaks down the system-wide algorithm to a row-by-row algorithm to maximize the production by reducing or eliminating the shading caused by undulations, slope, or construction variances on site. And the second component of TrueCapture is diffuse light tracking. So rather than the system continuing to track as if the sun's there in cloudy conditions, it orients itself to maximize production. And Andrew, can you touch on how frequently this happens and how quickly the system is able to reposition?
Yeah, absolutely. So essentially, the Data Hub is constantly monitoring and analyzing the irradiance measurements taken from around the farm. Based on that analysis, the system then actually makes a determination as to the control method on a 10-minute interval. So upon transition from, say, conventional tracking to diffused, the tracking system is able to then position itself accordingly in under 2 minutes. And just another thing to highlight, it's not just as primitive as just rotating the panels flat. There is some math and a bit of intellectual property there as to the exact angle that the trackers go to at any one time during diffuse light tracking, and most of the time they're not completely flat. So anyway, mentioned previously about an NX Data Hub. So lots of our clients have these already. Traditionally, they're an optional component for the system. Once TrueCapture is implemented on site, the NX Data Hub actually takes an active role in the system control. So yeah, it processes all of those GHI measurements and performs the control actions. Now, when TrueCapture is actually in operation. We got a great slide here, and a lot of people actually think that this is two different pictures kind of stitched together. However, it is in reality one farm where we have one block of trackers that is running the TrueCapture algorithm. The other block is just running standard tracking. As you can see it down the bottom, the bottom block is quite heavily shaded. However, the top block with TrueCapture enabled is completely shade free and is generating far more strongly. So just in regards to TrueCapture, we've got a lot of assets now deployed with this technology enabled. What that's allowed us to do as well, sorry, excuse that. What that's allowed us to do is really screw down onto our model predictions. And basically the ratios that between model and actual measured gain. We've got that down to around about 0.25%, which is great. What that means is if we analyze a site and if we're offering TrueCapture, you've got a high likeliness that you're going to get the production gains as advertised. Now, there is a couple of different M&V strategies that we've used to sort of determine this. Those can be alternating day. TrueCapture on versus TrueCapture off on the one block. If the blocks are similar, we can also have one block enabled and the adjacent one, not enabled. And over the course of time, we can then sort of analyze and sort of confirm those predicted benefits. So yeah, great advances there. Now, the next thing I'd like to introduce is our new software optimization, which we're calling NX Navigator. Now, I mentioned previously about the Data Hub and its role in the TrueCapture system. So the NX Data Hub is also able to run this software called NX Navigator. And NX Navigator is a web user interface that enables an operator to visually sort of see the farm, as well as perform, control actions and, initialize safety stows and things of that nature. So a couple of the main things that have been included in Navigator that's not currently available without Navigator is we're offering a hurricane typhoon, or more appropriately in Australia, a cyclone stow. Now, what that is for is when we are expecting weather conditions that are likely to surpass the capabilities of the tracker. So obviously the tracker is designed for a certain wind load. If we're likely to experience an event that's going to exceed that, we've got a stow strategy that is designed to minimize damage to the tracker. And what that does is, instead of a usual stow strategy where it's a dynamic stow at 30 degrees into the prevailing wind, in hurricane stow, we actually stand the panels up to a full 60 and position the tracker so that their torque tube is hard up against the bearing housing. And that sort of really stabilizes the structure and braces for that inclement weather. Now, a couple of other things that happen during that time as well is this also disables and prevents any other kind of stow condition from being enacted. So as you can imagine, you have a severe weather event. It's not just the weather you're worried about. You've got lightning, you've got power supply interruptions, chances are you've got network loss on the site. So with those sorts of things happening, you've got the potential that, the tracker can become, the NCU can become isolated from its peers. We can lose weather data, rebooting of hardware and things. So this hurricane stow ensures that the tracker stays parked where it was left until such time as the operator chooses to release it. In addition to that, we have also developed a hail stow, and we'll talk a little bit more on this shortly. And this sort of, allows us to protect the asset when we've got incoming hail. There's also functionality for yield improvement, not so applicable for the Australian market, given our climate, but we do have a snow shed functionality that can be triggered on demand, or, you know, if you know what the weather's looking like, it can be scheduled. And that essentially what that does is at a select time, it will tip the panels up, clear them of any buildup of snow, and then the trackers will automatically resume tracking. Again, we'll talk about this in a short while, but we also offer map view with Navigator, which is a geographically accurate representation of the farm, which allows an operator to kind of really screw in and look at the detail of the performance of you know, any one individual tracker or block across the farm. Now, just touching on hail, this is one of the big concerns for, you know, PV plants, and in particular, you know, insurance companies. So the picture that we've got on the slide here was taken from a plant in Texas that experienced a severe hail event in 2019. This hail event resulted in around about 400,000 damaged modules and an insurance claim that exceeded $70 million. So as you can imagine, it's a significant risk. Our hail stow increases the survivability of a module from 81% up to about 99.5%. So yeah, huge advantage there, and obviously, you know, insurance companies be very keen to know where these sort of safeguards are in place. Obviously, I spoke about how Hurricane Stow and Snow Shed previously.
And just to add to that, that's not our tracker in the picture there.
Yeah, good one, Andrew, thank you. So here's a quick video as well, just to visualize, you know, the differences between, you know, a stowed tracker versus a non-stowed tracker. So tracker on the left is just a typical tracker rotated horizontally, worst case scenario, versus a tracker that is stowed, and obviously, you know, the difference is evident right there. Now, I promised before that we were going to talk about hail stow. So here's a quick snip of what the Navigator controls look like. Now, there is actually 3 modes of control. Obviously, if you know the direction of the storm, you can elect to stow the panels east or west. We also have a third option, which is if something prevents you from enacting stow ahead of time, or, you know, unexpectedly we start, you know, receiving hail, we've got a fast react mode whereby the tracker will look to position itself to the nearest direction, thus sort of, you know, protecting the asset as much as physically possible. And then also, as promised, a quick look at map view. So what this offers is, mentioned before, a geographically accurate representation of a farm. A lot of our clients do not have particularly great SCADA implementations, which often makes it problematic for O&M teams to actually locate a problem with a tracker and orientate themselves around the farm. So, you know, this provides a lot of value there in just navigating farms, especially as farms are getting bigger and bigger. In addition to that, the system actually animates if there's any particular problem or fault with a tracker. And as I mentioned, you know, not all SCADA systems are created equally. A lot of our clients, they don't have the point count or are otherwise restricted as to what they can monitor. And therefore, you know, an O&M guy might be sent out to investigate a fault without knowing exactly what the fault is. With map view, you can highlight the tracker and get a clear, concise indication as to exactly what that fault is. Is it, you know, is it a low battery? Is it a motor stall? You know, is it panel low voltage? Those sorts of things. In addition to that, we also have included block level control. So any of the NCUs visible on map view, you can essentially select. And then we've got a number of control options. Obviously, you can transition from automatic to manual tracking. With manual, you can sort of choose what angle you want it to go to. And then we've also included an additional stow, which is mow-stow, which will rotate the field flat for as the name indicates, mowing. And then obviously we've still got the clean stow, which a lot of people on this call will be familiar with, where the trackers rotate each other. So we've also got a number of heat maps that can be applied to map view as well. So we can actually see which trackers are on target, what their angles are. And we're also working on integrating inverter data as well, so we can actually get a cool heat map of which blocks are performing better than others, and things of that nature.
Go to the next slide, please, Andrew. Go to extreme weather. So the root causes of PV failure, weather is the #1 source for PV insurance claims, as Andrew went into some detail on the hail. And then climate change is just making it so that there's more and more of these type of events. In Australia, the 3 extreme weathers what types of weather that we're concerned with are wind, hail, and flood. Most of the sites that we've worked on in Australia have some degree of flood height or another. And with that and extreme weather conditions, we'll be getting more and more rain. And so flood heights could increase versus what we've seen in the past. Most of the projects to date in Australia have been in wind region A and B, so relatively low wind speeds, but we're seeing more and more projects located in wind region C and D, which are cyclonic wind regions. So it's important not only to have strong wind engineering and wind tunnel testing to verify your design, but also to have some of the smart controls that NX Navigator provides. The same thing goes for hail. In the last few years, we've seen a couple very big hailstorms in New South Wales. Canberra had a very large one last year. And as I mentioned, with climate change, we're going to see more and more extreme weather. So having these safeguards in place through NX Navigator will mitigate some of the insurance claims that could come about.
So just in regards to the evolution of the product, obviously Nextracker has invested a lot of R&D into like wind tunnel testing, and mentioned previously that the tracker has gone through several generations of refinement and optimization, and that process is ongoing. So this is a good example of why you should look to partner with somebody that has the background and is investing that time and effort into the control system behind the tracker. In this example, we have a location that has 2 different tracking systems. The farm experienced a mild wind event that was around about the 50% threshold of which both farms were designed to handle. Our system, we are fortunate that it operated as specified. It protected itself. It incurred no damage whatsoever. However, the other tracking system, which had a slightly different stow strategy, incurred significant damage. And not only, one of the things that you've got to be aware of as well is, it's not just the damage of the asset that you have to factor in, it's also the time it takes to repair that asset and the lost production. So it really does pay to partner with somebody who has invested all of that time and effort into the R&D and are standing behind their product and further refining it as time goes on. So talking about further refining, we talk about wind regions, as Andrew mentioned before. We're seeing farms that are wanting to be built in regions that experience more severe and persistent wind. This is a good picture here. Again, fortunately, not our tracker. But you can see in the background that this particular farm has a lot of wind turbines. And that indicates that it's located in a region that is expecting strong winds, not only strong winds, but persistent winds. And that obviously drives around, product optimization is, well, look, how can you not only design hardware that is capable in these conditions, but what can be done with software to maximize yield? And with that, Nextracker has been developing a stage stow strategy whereby a number of trackers can essentially stow, protecting those adjacent to it. Obviously there's different thresholds before the entire farm would stow, but essentially if you're having a mild wind event, potentially you can still be generating energy whereby in the past you wouldn't have been able to. And following on from wind, obviously flood is a big concern. So the Nextracker system allows us to integrate flood sensors into the system. And not only that, but we're also able to break down where those flood zones are. So potentially, you don't have to stow an entire farm during a wind event, and the system can be a lot more specific, again, sort of promoting the maximum generation possible. Now, this is probably the biggest point we want to make during this presentation is the value of connectivity. So those of you out there who have already enjoyed the benefits of the NX Data Hub being installed on your site. So if you do have an NX Data Hub, what that allows us to do is it essentially pulls data from the NCU and gives us a holistic view of the farm operation. And with that, we can offer a simplified and more speedy warranty replacement process. So I'll give you an example. If you did have a problem with a tracker or something, we could have a look at the trends building up to the failure. We can confirm root cause and basically dispatch parts directly to site with minimal delay. Whereas otherwise, we might have to work with O&M vendor to sort of triage what's wrong with it. Is it a panel? Is it a battery? Is it a motor? Or a number one of 100 permutations of things that can go wrong. And not only that, but the data that we're able to collect and analyze, this is what's really driven the evolution of the product. And that's resulted in, system optimizations, improvements to the NCU menu system. And that's come about in the form of regular firmware upgrades, which we're able to return back to our clients. So just further cementing the point that you're buying or investing in a product that the day you bought it, 10 years later, it might be far more productive and beneficial just through the continual evolution that we're doing. And therefore, the more high performing the asset, the lower the O&M costs and the more return on investment. So obviously mentioned, what we're able to do with, just data in general. And that sort of feeds into this predictive analytics part, and especially what we're trying to promote here, which is reimagining O&M. So O&M historically has been very reactive, as in, you get a problem, you go and fix it. Well, what if you can detect a problem before it occurs and then look to schedule fixing it at a time that's opportunistic? And I'll just refer back to a slide that we've seen previously today, just where where the O&M component costs are. So obviously we're constantly working towards minimizing any O&M encumbrance. So and we can definitely do this on the tracker as well. So what can we do? Well, firstly, obviously we can monitor the plant performance. We can monitor what's going on. We can also then, perform diagnostics, as in, we can work out what led up to the failure. With that, we can then also predict when that failure mode might present again. And then if we can do that, we can also then be prescriptive, as in, you know, what can be done, when can it be done, and in what time frame it needs to be done in. So just to give everyone a bit of a background, currently we have quite a wide visibility on tracker performance. And at the moment, we've got data on the performance of about 350,000 trackers in our data warehouse and about 3 terabytes of data. Now, this has kept our diligent analytics team extremely busy. They've been basically crunching the numbers, looking at component failures, and, you know, that's allowed to give us an idea of, you know, what component failure will result in how much downtime. It's given us insights into what are the root causes. And obviously, as I mentioned before, it allows us to look to predict. And I do have a bit of a case study here, which is a great example of some of the good work that they've been doing. So in this instance, we've got a case study on a lower damper mount, which has slipped. Now, this was a problem more with the older NX Horizon system, whereby the damper mount was nut and bolted, and you know, obviously it relied on the bolts being adequately fastened in the first place. Obviously, you know, weather events and things could impact that vibration, and then, you know, unexpectedly the damp could, you know, come loose and start slipping. And you can see a trend here, which is a trend over about a month of the motor current for that particular tracker. And essentially what you can see is as the tracker approaches an angle of 60 degrees, we start to see small spikes in the motor current as it approaches that 60 degrees. And these slowly get more severe as that damper continues to slip down the pier until such time as the tracker becomes stalled. Now, what that allows us to do is that allows us, well, that's essentially a failure signature. And that allows us to review data that we've collected, specifically looking for this signature. And in doing so, what we can do is we can then forecast. We say, well, righto, this tracker here, we know it's got an issue. It's likely to cause you a problem in, you know, say 3 weeks' time. The consequence, if you don't resolve it, is, you know, a tracker stall. And what that allows you to do is it allows you to cluster your O&M. You know, a lot of the farms these days are unmanned, they're remote, especially in the Australian market. So any optimization of O&M is of huge value. I mean, why would you run a truck to site 3 times in a reactive manner when you can forecast, predict, and schedule? And so just carrying on from that trend, we have been working really hard to produce failure signatures for lots of, you know, pretty much all the different components on the tracker. At the moment, we've got signatures for obviously damper slips, water intrusion. We can actually detect, you know, BHAs and things that have not been fastened appropriately straight from the construction stage. We can pick up on, you know, 30 watt modules that are starting to fail, motors that are showing signs, you know, so lots of really cool things are coming out of our analytics section. And yeah, that leads us into some of the other offerings that we've got. So Andrew, do you want to take lead on this, just from the sales front?
Yeah, sure. So one of the things that Andrew had mentioned was digital O&M. So what he was just touching on, monitoring and predictive maintenance. We went through TrueCapture and Stow, NX Navigator, and then software tools for site management, such as the Data Hub that we're putting on every site, and then Tracker CX, which is another site management tool. And on the services end,
yeah. So just in addition to that, we've obviously got training on, you know, the farm O&M and construction via our PowerWorks program. We're also offering training on our engineering software as well. That can be tailored to you know, be delivered on site or at one of Nextracker's premises. And then, you know, obviously we offer the usual you know, excellent technical support and service that that we're famous for.
After this presentation, you'll receive a follow-up email, which will include some additional resources. We've got a handful of white papers that cover some of the topics that we discussed today. This is also the second in many upcoming presentations, different regions. So if your colleagues are in other regions or geographies throughout the world, feel free to let them know. And then our media partner, Solar Plaza, they've got a series of virtual shows this year, and one coming up in Australia is in November. And you'll also receive information regarding that conference in the follow-up email.
And Ali, I think we're on to the Q&A now.
We are. Thank you so much, you guys. This I think has been really helpful for maybe some people who are familiar with Nextracker and maybe just a little bit more on our offerings. And for everybody who's new, welcome to Nextracker. We do everything. So we're going to go down just a list of questions that we've received. Let's see. So this is for Andrew. I'm not sure which Andrew, but one of you guys can figure it out. Do you need string level monitoring to provide the feedback for TrueCapture?
So, yeah,
go ahead, Andrew.
Yeah, I was going to say we don't need string level. We do need inverter level as a minimum. I mean, look, really it comes down to what you require for the measurement and verification process. If that level of monitoring is available, that is fantastic. You know, we can use that to sort of, you know, confirm that the system is operating as best as we can get it, and obviously we can then use that to verify, you know, any improvements or tweaks to the system or optimizations. You know, so it's good to see before and after.
Andrew, do you want to add anything?
No, I think that covers that question.
All right, so another question came in for TrueCapture. Can the additional gain by TrueCapture be modeled by any industry software, such as like PVSys?
No, it cannot be modeled in PVSys. We've developed our own tool to predict the gains on a specific site. And what we've done is we've had this validated by numerous third-party independent engineers to validate, here's the production that we're modeling versus what we actually see on site.
Okay. Let's see. What kind of sensors is Nextracker using these days to detect an oncoming weather event?
So at the moment, we have several different offerings. Obviously, we've got ultrasonic wind sensors. We've also got ultrasonic flood sensors. These haven't really changed much. We also do obviously have irradiance sensors for the TrueCapture aspect. I know there is talk in the background about possible hail sensors and things like that. But yeah, those three are the main ones at this stage.
Okay, maybe can we talk a little bit about Gemini? So 2P, it's our latest and greatest tracker offering. Is this available now in Australia?
Yes, it is.
Cool. And do you guys want to talk maybe a little bit about how Gemini differs from Horizon? Just basic differences on the two trackers.
Yeah, sure. So Horizon is a 1-in-portrait tracker. Gemini is a 2-in-portrait tracker. While Horizon is powered by a slew drive in the center of the motor, or in the center of the row, so just one motor and one drive system per row. The Gemini system actually has a series of actuators at some of the posts throughout the tracker row. And so what this does is it creates a rigid structure that actually cannot move. And so it's very stable at high winds, which is kind of not what the industry thinks of when you think of a two-piece system, but that is because it is engineered differently. And one of the other big differences is that while we use a smart panel on the Horizon system, the Gemini system is either hardwired or string powered.
Great. Any other last words or last questions from you guys, or any other last comments that you guys want to make? We're running a little bit ahead of schedule today.
No, I think if anyone has any additional questions, either we have a few minutes to raise them now, or I believe that me and Andrew's information is provided afterwards. So feel free to shoot us an email, and we'll get back to you with any questions and or just material that you're looking for.
All right, so if that's the case, then for everybody who's out in our audience, thank you so much for joining today. You will receive an email with all this information probably tomorrow, so just keep an eye out for it. And it will have Andrew Chino's and Andrew Little's information. So if there's any additional questions, please send it our way. Thank you so much, and this concludes our webinar for the day. I hope everybody has a good day and stay safe. Bye.
Thanks, everyone.
Thanks, everyone.